The objective of this lesson is to organize the subcategories of quadrilaterals in a hierarchy. In previous lessons, students have learned about the attributes of various quadrilaterals. Today, they will extend their knowledge to create subcategories based on the quadrilaterals' relationships. A hierarchy is a system in which groups are ranked according to power, authority, or structures. Some real-world examples include the United States government, families, ecosystems, and so on. Let's look at the government organized two different ways. Let's use a tree diagram first. The Constitution dictates there are three branches of government: the legislative branch, executive branch, and judicial branch. Then each of these branches has several agencies that are subcategories of that branch. This type of organizer places the overarching category at the top and the subcategories beneath. Each item is a subcategory of the category or categories above it. Another way to organize would be to use a concentric shape. Whatever lies within a shape is supervised by the organization represented by that shape. For example, the president operates within the executive branch and he oversees the vice president and his cabinet. Quadrilaterals can also be organized into a hierarchy. Previously, students learned that all parallelograms are trapezoids, and all trapezoids are quadrilaterals. They would be organized into a tree diagram like this one. To organize into a concentric circle, we will start by drawing a large circle and label it quadrilateral, because all trapezoids and parallelograms are quadrilaterals. Next, draw the trapezoid circle inside the quadrilateral circle to show that trapezoids are a subcategory of quadrilaterals. Finally, draw a parallelogram inside the trapezoid because every parallelogram is a trapezoid. Now let's use another set of quadrilaterals, rhombuses, rectangles, and squares to organize into a diagram. Let's start with the Venn diagram. We will draw three overlapping circles. Label the red circle quadrilaterals, the blue circle rectangles, the yellow circle rhombuses, and the centerpiece squares. Squares are in the middle because all squares are quadrilaterals, rectangles, and rhombuses. Let's start by sorting some rectangles. The first two rectangles have four sides, but they are not all the same length. These shapes will go in the overlap of the quadrilaterals and the rectangles. The third rectangle has four congruent sides. It is a square. It will go in the centerpiece because it is a quadrilateral, a rhombus, and a rectangle. Let's sort some rhombuses. The first three rhombuses all have four congruent sides, but no right angles. They will fit in the overlap of rhombuses and quadrilaterals. The last rhombus has four congruent sides with four right angles, so it will go into the square piece. Now let's bring up four more quadrilaterals. All of these shapes have four sides, but none have four equal sides, and none have two sets of parallel and congruent sides. These are just quadrilaterals and will be moved into the non-overlapping quadrilateral portion. Notice that the rectangle and the rhombus all overlap with quadrilaterals. This is because every rectangle, rhombus, and square is a quadrilateral with four sides. Therefore, these areas can be set within the boundaries of a quadrilateral. The Venn diagram could be redrawn using concentric circles. The quadrilaterals will be the outermost circle. The rhombus circle will overlap the rectangle circle. Where they overlap will be labeled squares. Now let's reorganize the concentric circle into a tree diagram. The top, or overarching category, is quadrilaterals. Next, rhombuses and rectangles are both examples of quadrilaterals. Squares are both rhombuses and rectangles as well as quadrilaterals. Let's use the diagram to answer a couple questions. Are all squares rectangles? The answer is yes. Looking at the concentric diagram, the squares are included inside the rectangles. So yes, because a rectangle has two sets of parallel sides and four right angles. Are all rhombuses squares? No, because in the tree diagram, the rhombuses are above the squares. Only if the rhombuses have four congruent sides and four right angles can they be categorized as squares. Squares are examples of rhombuses, not the other way around. The objective of this lesson was to organize the subcategories of quadrilaterals in a hierarchy. We met this objective by using Venn diagrams, concentric circle diagrams, and tree diagrams to organize quadrilaterals into their correct subcategories.